All right, so welcome to Module 2, which is scientific notation and unit conversions. And again, things that are huge in chemistry, so if you are feeling solid on these, that is totally fine. And you can skip right to the quiz. But let's quick talk about what is scientific notation. Well, anytime that we have numbers that are really significantly larger than 10, and when I say significantly larger than 10, I don't mean 15, okay? I mean numbers with a lot of zeros after the number. Or if it's significantly smaller than 1, and I do not mean 0 or negative numbers. I mean numbers that are 0.00007 or something like that. We use scientific notation as a way to write less zeros that are actually currently serving as placeholders. And that gives us an easier time of writing numbers down. So we have these quite often. Let's take a couple of examples. Let's take a look at a couple examples. That's good English right there. So if we have a number that's larger than 10, for this example, we have the diameter of the Earth. Well, the diameter of the Earth is 6,370,000 meters approximately. Well, I don't want to write down 6,370,000 every time I'm writing it down. Every time I'm writing down if I'm trying to calculate something with it. Okay. So instead, we move the decimal place to the left to make the number smaller or less. We get rid of some of these zeros, and even if they're not zeros, we'll still often get rid of them just because they are insignificant in our calculations at times. And then the remaining number is left as 10 to the power. So here we have 6,370,000. So normally my decimal point, let me change colors, that's not good. My decimal point's right here at the end. So what I want to do instead is I want to move this decimal point. So 1, 2, 3, 4, 5, 6. So instead I have 6.37, and instead of having all these 6 places to the right of that, I have times 10 to the 6th meters. So I move the decimal point to the left. Since I moved it 6 steps, it's to the power of 6. This is probably something, God, I don't know, 8th grade, 7th grade that you guys started doing this. So it's nothing new, but now we're actually going to be using that quite significantly this year. So we want to make sure we understand why that is. All right, what about numbers that are smaller than 1? Here, example, we have the diameter of a red blood cell, right? Something very small. So it is 0.0000075 meters. So again, in this case, I'm going to move the decimal, but I'm going to move it the other way. So right now, that decimal is right here. I got 1, 2, 3, 4, 5, 6 places. So now I always want 7.5 something, right? I want a number with the decimals towards the right, but only one number is on the left. So I got 7.5 times 10. Well, it's to the 6th, but because I moved it to the right this time, it's 10 to the negative 6th meters. So we're making the number much smaller than 1, and now I don't have to write all these zeros anytime I'm doing this. Now there is one more step to this, and that'll get us into our next concept, which is metric prefixes. Instead of always writing down 10 to the power of a number, we can replace that 10 to the power of a number with a metric prefix, or slightly manipulate our scientific notation. Normally we have it's always 5.20. Maybe we change it to 520. So to help us with our metric prefix. And I'll get to that. I'll get to an example in a little bit. So for an example, we have 1,000 meters. Well, 1,000 meters, instead of writing down 1,000, it's 1 times 10 to the 3rd meters. Well, you might say that that's probably just as much or if not more work, and you would be absolutely correct for that. But instead, 10 to the 3rd, if we look at our metric prefixes, is a kilo or K. So we can instead do 1 kilometer. Right? So that's way quicker. 1,000 meters is 1 kilometer. Or we have this, oh my God, 0.0000623 meters. Well, that's 6.23 times 10 to the negative 6 meters, which is way better than writing down this long thing here. Or I can call it 6.23 micrometers or micrometers because I have 10 to the negative 6. 10 to the negative 6 is micro, so I can make that micrometers. Now, if something doesn't perfectly line up, and here comes back my 520 shenanigans, let's say we're talking about stuff like the wavelength of light, not covered in the scope and sequence of our class, but wavelengths of light are often talked about in nanometers, so 520 nanometers. Well, what would that look like in scientific notation? Well, it'd be 520 times 10 to the nano is negative ninth meters, okay? Well, normally I would actually have 5.20 times 10 to the, will be negative 7th meters. So this 10 to the negative 7th, that isn't anything. So I moved the decimal 2 place, 520 times 10 to the negative 9th. So that's why, or that's how we could manipulate that. Let's do 2 more examples and call this good. So here our examples are again that we talked about before. 6.37 times 10 to the 6 meters. Well, that's simple. If I go to my table, and this table is provided on your AP Physics 1 formula sheet. It's not expected to be memorized, but most of you probably have that already. That's 6.37 megameters. 6.37 times 10 to the negative times 10 to the 6th. And here we have times 10 to the negative 6th. So negative 6th, that's micro. So that's 7.5 micrometers or micrometers. So just a way easier way of writing stuff down than this right here. One thing we'll see a lot in our last unit is going to be nano times 10 to the negative 9th. So we'll have like 6.67 times 10 to the negative 11th. You know what, let's not worry about that right now. So we'll see some of these later on. This has to do with Newton's gravitational constant, but never mind. Okay, so yeah, there we go. Boom, boom, done. Okay, so the other half of Module 2 is talking about unit conversions. And again, unit conversions is something that you probably spent a ton of time in chemistry, if you took chemistry, which most of you did. Now, I did not have an appreciation for this at all in the chemistry terms until I got into much deeper stoichiometry, which I took in quantitative analysis. And stoichiometry actually does a lot, but that's not something we're going to worry about. And if you thought stoichiometry was hard in chemistry in high school, just wait till you get to upper level chemistry in college. In physics, though, we only really do unit conversions. So here's a really basic example. If I want to convert units, I need to set up what are known as conversion factors to get from one unit to another unit to cancel out those units to go from one unit to the next unit. So here I have 60 miles. If I want to know what 60 miles is in kilometers, I need to set up what's called a conversion factor. So this guy right here, my 1.609 kilometers in 1 mile. That is our conversion factor. That could be inches to feet, centimeters to meters. It could be yards to meters, right? It could be going larger or smaller within a system, either the metric system or the US system, or it could be going from a system to another system like metric to US. So knowing that 2.54 centimeters is 1 inch. That is known as a conversion factor. And that is how we get from one unit to the next unit. So this is a very simple example. Let's take a look at a couple different examples. 16.7 kilograms is how many grams? Well, you might say, well, can't we just use our metric prefixes? Of course you could. That would work. But let's do this correctly. So 16.7 kilograms. And we're trying to get that to grams. So in order to do that, we need a conversion factor. And my conversion factor is there is 1,000 grams is in 1 kilogram. So where do I put this? Well, the way that I always think about it is my units need to cancel. So if I have kilograms on the top right here, I need to have kilograms on the bottom right here. So that is my 1,000 grams. So 16.7 kilograms is 16,700 grams. Very, very simple, okay? I just realized that I have the same question down here twice. So instead of doing that, let me go ahead and say something else. and ask instead 15 years is how many seconds? Now, again, we're not going back and forth from systems yet, but 15 years is how many seconds? So we got to set up our conversion factor. Well, 15 years. Well, I don't know a conversion factor right away, so I might have to use a couple conversion factors. I do know that 1 year is, well, depending on how specific I am, which I am a big specific person, 365.25 days. That's why every 4 years we have a leap year. And then I know, as I'm running out of room, that 1 day is 24 hours. And if I continue to set that up, I know that 1 hour is 3,600 seconds. So with the conversion factor, I multiply across the top, divide across the bottom. That's actually really easy because there aren't nothing but ones on the bottom, which is not always going to be the case especially when we're going from system to system. So that's my setup. I do my 15 years times my 365.25 days times my 24 hours times my 3,600 seconds, and I get 473,364,000 seconds. That is how many seconds are in 15 years. It's quite a bit. Now, my last example, now I have a little bit more of a complex thing. I have meters per second. So when I think about a meter per second, that's like a mile per hour. That is a distance over time. So I get 2.998 times 10 to the 8th meters in 1 second. So when I set up my conversion factor, I need to think about both of them. So let's think about the meters first. Well, we're going from meters to kilometers, so I know that there are 1,000 meters in 1 kilometer. And at the same time, I am going from seconds to hours. So I know that there are 3,600 seconds in 1 hour. And if I look at how my units work, my meters cancel with meters, my seconds cancel with seconds, and I am left with a kilometer per hour. And that is how we do our unit conversions. So if I go ahead and plug this in, I got 2.998 times 10 to the 8th meters per second times across the top, so times 3,600, divide by across the bottom, that's divided by 1,000, and that is still a lot of kilometers an hour. So plug that in your calculator. I got 1,079,280,000,000. So if you got that, you should be good. This is the speed of light. This is actually a really useful conversion if you're ever thinking about how far away like another planet is, or how long it would take us to get there, whatever. So that is the speed of light going from meters per second to kilometers per hour. It's pretty fast, right? So those are just a couple examples. Some of the more complex examples would be like, how tall am I in meters? So let's do that one real quick, and then we'll be done with it. So myself, I'm 6 feet 4 inches tall. So if I want to get that into meters, well, 6 feet 4 inches, that's not very useful to us. So let's get my 6 feet 4 inches into just inches. So 6 feet, that's 72. So I'm 76 inches tall, and we want to get that into meters. Well, I know that 1 inch is 2.54 centimeters, and there are 100 centimeters in 1 meter. So I would take this gets me this middle step here. This is my conversion factor to go from US to metric, and then this is like my conversion factor to get to the right side. So if I have 76 times 2.54 divided by 100, I am 1.9304 meters tall. So again, That's called a unit conversion, and we use those to get from one unit to the other unit. We use those to resize our units. There's a lot of different things, and you just need to be comfortable doing those, which many of you probably are. So awesome. So good luck, and next would be the quiz, or either do the practice or take the quiz.